Hi, what I'm going to be doing today is showing you the derivative of y equals natural log of x. Well, what I'm going to do is start off with a quick identity. Or should I say, looking at this in a different way. I can say e to the y is equal to x. Well, and now I'm going to find the derivative. We already know the derivative of e to the y is e to the y from a previous video or previous lesson from your calculus class. So the derivative of e to the y is e to the y dy dx equals x. The derivative of x. The derivative of x happens to be 1. Now what I'm going to do is divide both sides by e to the y. So we can say dy over dx is equal to 1 over e to the y. But wait a second. Let's look at what e to the y is. By substitution, we turn around and we say dy dx is equal to 1 over x. So y prime, the derivative of natural log of x, is equal to 1 over x. We're finished. With that, let's do one or two simple examples, and we're going to incorporate the chain rule. Let's say I ask you to find the derivative of x squared plus 3x. Well, the derivative of the natural log of x squared, I should be able to say f of x equals. So the derivative of this will be 1 over x squared plus 3x times, working with the chain rule, 2x plus 3. So your final answer is 2x plus 3 is equal to over x squared plus 3x. Let me do one more example working with finding the derivative of natural log. But this time, let's say f of x is equal to natural log of sine x. Well, by working with this, f prime of x is equal to 1 over sine x times the derivative of sine x, which happens to be cosine x. So we're left with cosine x over sine x, which happens to be cotangent x. And now it's just a matter of playing and working on other examples, but following the same pattern, the same steps involved. But equally important, or more importantly, is understanding where it comes from and how you do it. So if you do forget the rules, you can always go back and redo the example from scratch. Thank you and have a good day.